Streaming. Hello, welcome to another day of XR Talk Show. So today we are going to do Advent of Code number 5 in Emacs Lisp. So Advent of Code number 5, okay? So we did Advent of Code day 5 in Wolfram language before. So this is a page, Advent of Code day 5. So the problem is given this input, those textual graphics indicates boxes. So you have boxes stacked on top of each other, and your task is to follow some procedure to move them. So that's a problem. But this time we're gonna do it in Emacs Lisp. Okay. Emacs Lisp. Okay. So let's begin. So this is requested from our friend Jacob L. So Advent of Code XR Discord if you have not already joined, and preferably use your real name and real profile photo. So because we want to talk about real life stuff, we don't want memes, Chan, we don't want garbage. So if you join, talk about real life stuff, your friends, your work, your family, real life, not the typical website, Reddit, Hacker News, whatever you talk about bullshit. Personal, okay? So anyway, so today coding Emacs Lisp, we're gonna do this problem. Secondary account, hello. Emacs Lisp. So if you don't know already, I'm gonna tell you my keyboard, this one. I'm promoting them because they sent me one, and I love this keyboard, really. So you go to XRD, search for ergonomic keyboards review, XRD, and you'll find Expose, okay? While I'm talking about this, I recommend, Kinesis Advantage I've been using for 5 years, but now I'm changing for a change. I'll switch back anytime. And Kinesis 360 is also excellent. And this Glove 80 is also, I recommend, excellent, okay? Not so much Motron because, this thing is $500. You have to take the cost into consideration. And right now I'm using this Expose Night. Fantastic. Okay, you go buy it. Not expensive. Okay, I recommend it. I don't get money if you buy it because this one is not on Amazon. But they have sent me prototypes since like 4 years ago, since they begin. So, and I truly love this keyboard. So this I'm only saying the things, true opinions, the things I love. Okay, and this one is also, I discovered this one about last month, and this Alice layout is also great because it turns out they have less stagger. So this is Alice layout with less Wonderland. Alice without much Wonderland. This is Alice layout. Very interesting naming of things because Alice, the reason this kind of layout is called Alice is because it's like it doesn't make sense. First, it's split, but then the left-hand side uses, it has stagger. It still keeps the traditional. So it's kind of like weird. Alice, like Alice in Wonderland. So anyway, so this is my friend, my old YouTube watcher, Zumbo Ben. He's a keyboard collector, so he has a lot of interesting keyboard, and he sent me photos of it. Let me put down my website. So anyway, Alice layout. It's so I discovered this one. Okay, so. So many to choose from. Let's go back to Ergo keyboards. So this is great. This is Kinesis Advantage, great. Kinesis 360, great. Glove 80, great. I recommend. Expose, great. I recommend. Apple Maker, Alice layout, I recommend. Israel, this is also fantastic. But it's over $500. So this, no, no good, okay? Got several problems. And then the more common ones, okay? And then there's also some of these. Anyway, so that's about keyboard. Let's do the Emacs Lisp coding of advanced code, okay? So let's begin doing that. That's the main topic of today. Show in browser, today's talk show, fantastic. Let's do the problem. Hello, Luis, good morning. Yeah, we haven't done Emacs Lisp for a while. Any advice on some of the best ways to protect IP, especially for independent? Well, that's I don't know much about that. Okay, you want to protect your IP. Basically, you cannot. Actually, if you want me to give you one sentence summary about how do you protect your IP, you're talking about IP address, right? Basically, the answer is no, you cannot. Any website you visit, it will be known by CIA, by FBI, by Google, by Apple. Any website you visit, doesn't matter. But I know Onion, but I know the private network. That's all bullshit. Okay, every website you visit, keep in mind that everybody knows. Everybody, those who wanted to know, they know. Okay, there's no way around it. Okay, so basically, okay, gets into complicated detail. Okay, let's get on the topic. Okay, so advent of code. Let's visit the problem because I forgot we have to go to the problem. Advent of code, day 5. Okay. Oh, I still have it logged in. So day 5. Oh yeah, so last time we stuck on day 7. But anyway, so let's do day 5. Day 5, the problem. Okay, so you got this input, a text. Each column indicates a stack of boxes. The problem, okay, so what is the problem? There are 3 stacks, okay. Stack 1, okay, so let's put here so you can see. Stack 1 contains 2 crates, okay. Then you arrange, so you have a crane that moves these boxes, but you can only move one at a time. So, and what is the problem? The second step, okay, so, so you are given, these stacks, but you are also given this procedure. So sample input. So let's actually get it to Emacs. Okay, so advent of code problems are kind of so input is like that. Okay. So you have the stack of boxes, but you also have this procedure, move one from 2 to 1. So move one box from column 2 to column 1. Then move 3 boxes from column 1 to 3. So, but each time you can only move one box. So this basically, so when you see move 3, that means repeat it 3 times, okay? So you given this procedure, then you have to follow this procedure. Then the answer should be which boxes, what order of the boxes is in column 1 and column 2 and column 3 and so on. Wait, is that true? No, they just want to know what's the topmost box in each column. Is that right? So let's see. So the elves needs to know which crate will end up on top of each stack. Okay. In this example, so the output should be just a string of letters. The first character is the topmost box in column 1. The second character is the topmost box in column 2. So that's the problem. Okay, so let's do this in Emacs. Okay, So in Emacs, okay, let's begin with the with the sample input, okay. So let's begin. Text, okay. So this is the input. This is today's problem. So let's code in Emacs Lisp. So first problem, okay. So let me tell you what we're gonna how we're gonna do this, okay. Emacs Lisp. So first of all, okay, it's probably easier just to do it than talking about it. Okay, so let's begin the Emacs Lisp code. Okay, so here is the input, and you can assume it's a string. Emacs Lisp, you have the different, the nested parent syntax. Okay, hold on a second. So let's move this. Okay, so set input x input to this string. Okay, so that's the input. So first of all, split the input into two parts. Okay, input 1, input 2. Okay, set input 1. Okay, so what we're gonna do a split. Okay, so split. Okay, the split string. Okay, split string. So we want to split the string x input by separators, which is 2 new line character. Okay, omit nulls. Do we want to omit nulls? No, we don't care about that. Okay, so so this, we're gonna create a variable input parts. Okay, so set input parts equals to that. Okay, then set input, so we get input part 1, okay, equals to input to string split, that returns a list, I think. Let's see what it returns. Bounded by match separators. So split string into substrings bounded by, yeah, but what is the structure? I think it's a list. Okay, we can do it. Okay, just okay, evaluate that part. Okay, and evaluate that part. Yeah, so we have a list of 2 strings. Okay, so the first part, you can say nth, stupid Emacs Lisp. Okay, so x input part nth 0. Okay, that's how you get each part 1. Okay, now before we do this, let's change the variable names. Okay, input parts, stack boxes text. Okay, let's change the name to something that's more intuitive, and procedure. Okay, so we got these variables. Okay, now evaluate it, evaluate that, evaluate that. Okay, now let's go to the messages buffer. What is this? Yeah, let's see, let's evaluate, let's see the variable. Yeah, that's the variable x boxes text. Okay, and describe variable procedure. That is correct. Okay, so split them. split the input. Now, what's the next step? Now we want to basically this visual stack, we want to make each of them, each of the column into a list. So in Lisp, lists is a suitable data structure for stack. A stack is like a data structure in computer science. And what a stack means is just like a stack of books where you can add new items to the top and you can remove one item from the top. And that's the only two procedure you can do to a stack. So, like a stack of books. So that's a computer science data structure, okay? And to represent that structure in Lisp, we want to use a list, okay? So we want to turn basically this text into several lists. Each list represents a column, okay? So any comments, questions, say it, okay? Oh, you are talking about intellectual property. Best way to protect intellectual property. Well, never go open source, okay? Never do open source. Again, that's complicated, okay? There's, you can patent it, things like that. But the open source has corrupted the entire industry. So if you want to protect your intellectual property of code, well, good luck. Basically, it's very hard to do. The open source fanatics, they will steal your code by all means, I mean, it doesn't matter if you are a commercial company like the Hollywood, they produce movies, the open source fanatics, by day, they say, oh, we are for the prosperity, like the richer, well, they are for the prosperity of society. Everything you must share. By night, they steal Hollywood movies, the rip the lots of website, that's what they do. And by day, they work for proprietary corporations like Google, Apple, Facebook, They release some code that's open source, but actually their money cow is not, none of it is open source. For example, Chrome web browser, the open source fuckheads, they will say, oh, Google Chrome is open source. Not really, like the Microsoft VS Code. Well, yeah, the core is open source, but good luck if you really want to build it. The actual cream is not open source. So you have the, the corporations took over, using this open source, and the open source fanatics by day, they work for this Google. They make a lot of money. Google, Apple, Twitter, including Facebook, By night, they sing the songs of open source. They churn out open source stuff on GitHub. So what happens? So it robs, if you are a good person, you don't work, for this 1,000 lawyer patent fucking corporations, but you have no way to survive. The only way is you go off Google, these open source fuckheads, putting their stuff on GitHub. Okay, that's what I say. And the cycle, they lie to themselves. They think, oh, Twitter is proprietary. Oh, Discord is proprietary. I'm going to use some, open source, some stealing, rob the protocol. They create their open source version using Discord, but Discord doesn't want you to do that. But anyway, they do it anyway, because they think, oh, open source, what happens if Discord went out of business, therefore blah, 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 blah. But in the end, what really they want to do is they want to steal. They want to reap the advantage, whatever good things you offer, but they don't want any pay. They don't want to pay. They don't want to whatever. And then Discord, Discord is not open source, but lots of other things. They sold out. They sold out to a commercial entity. Like Java to Oracle, and endless history. Then these people, they the cycle, repeats, like the open office, then becomes star office. MySQL is still open source, then got, endless stories, but they don't listen. It's pretty bad situation. So what I support, I want, let's go back to proprietary companies who never have any controversy about stealing, about, nasty things, okay? You trust people, you pay for whatever they do. Pay me, okay? Pay me for, if you like my YouTube, pay me. Okay? You pay for the services. And as soon as they did something nasty, like they created hidden code that grabbed your information, something like that, then you get them, have the use law, get them to jail, okay? No, there's no leniency, okay? So if Apple, for example, they sell, phones, then whenever they have a new phone, they put code so that your phone becomes slower. That's a crime, okay? When that happens, the CEO of Apple go to jail. It's not like, oh, Apple did something bad, therefore I'm gonna use Android. No. You want the Apple CEO to go to jail. Okay, not penalty of 1 million, 2 million. That's peanuts. Okay, that's 1% of what they do, what they did. Okay, that's what your mentality should be. Trust, trust, and integral. The person, the CEO, whatever, and including yourself, integral. If you truly believe in open source or free software foundation, fine, but then you should never steal Hollywood movies. And when you see those websites, Pirate Bay, report them. Okay, if that's actually you truly, and you should never work for proprietary company. Do that. Okay, if you do that, you are great, and I believe your open source. I myself, I was a free software foundation Richard Stallman fanatic 20 years ago. Okay, anyway, let's go back to Emacs. Okay, so we split. Now we want to turn this into a list. Each column needs to be a list. Okay, so first of all, we want to parse each line. Okay, so but before we do that, let's try to get a more complete input, so that we can see, this is an example of bigger input. Okay, so each column, so first of all we need to, so right now we want to turn this text into, so that each column becomes a list of things. Okay, but there's no way to directly get a column. So what we do is that we take each line and we pass it into a list. Then we want to do a kind of like a matrix transposition. So column becomes rows, rows become columns. Okay, that concept is very well known if you do linear algebra. So in Wolfram language, there's a built-in function, transpose, okay, but you cannot do it in Emacs Lisp. You have to write it. So I don't think, so that will take some time. So anyway, so let's parse this. So each line is like that. So each line, you can notice that each character, each box is 4 characters, okay? So we want to split the line into by every 4 characters, okay? Split the line by every 4 characters, okay? So let's go back. Oh God, I don't know how long this will take. Per line into 4 chars into a list of 4 chars, something like that, okay? So this is box's text. We want to process this, okay? So you want to split the string. So first of all, boxes, okay. Okay, let's use elaborate long name. So first of all, so you want to, yeah, so list, so you want to first of all split string, split that by, okay, so by new lines. So now we got a list of lines. Okay, so this is a list of lines. Okay, let's do it. Okay, let's describe variable. That's right. Okay, so you have a list of lines. Okay, so now for each of the list element, we want to, each element is a line of string. We want to split again by every 4 characters. Okay, okay, so you map this function to that list. Okay, so what is the function? So the function, every 4 characters, okay, every 4 characters. How do you do that? I don't know. So let's look up all the string functions in Emacs Lisp. Okay, so Lisp basics string functions. Let's see if there's a built-in function. I don't think so. Split string to number, split string optional separators. Hot. Any comments, questions? Okay, so let's focus. Okay, so split by 4. So regular expressions, can we use regular expressions? So more string functions. Let's see, make string. So we have a string. For every 4 characters, you want to make it, push it as a element. So okay, so this problem is actually fairly complicated, a lot to do. String collate less p, whatever. String distance, associate string. So it's Jacob. Jacob, are you here? Jacob kind of requested this. Jacob asked me to do this. Okay, so concact append by to string down case, set case. So all these are case. So I don't think there's a built-in function. Let's see. A string, you want to split it by every 4 characters. So there are a few ways to do it. Let's think about it again. So every 4 characters. Down case append string to char. A Google user, hello, I'm not here for programming. I'm working on my own project, but I hope that everyone here is having a good day. Hello, Google user. So Let me think about it. So we can use regular expression though. Okay, so first of all, we want to know the number of columns. Okay, that's easy. That's the last element and the last number. So let's set number of columns. Okay, set q, and that would be the last. Okay, okay, there is no, so last item of that. Okay, then you have to do car, which is a idiotic Lisp cons. So basically this will get you the last line of these boxes. Okay, then once you have that, you want to split string again. You want to split by white space. Okay, separators white space, space one or more, and you don't want omit all, omit null. So split string of that thing. Okay, that's what you want. Number of columns. Okay, so if I evaluate this, you see, so you get the last item car, then you split it by, then you split it by a space, then you want to get the last again. 1 2 3 4 5. Now you want to get the last, so so you want to do car last. Okay, essentially that's the code. Okay, let me clear it this way, it's easier to see. And let's make it X. Okay, so let's evaluate that. Okay, done. And now let's describe variable. Number of columns value is 3, correct. Okay, so we got number of columns now. Okay, now we go back to the split each line problem. So given a line, you want to split every 4 characters. How do you do that? Every 4 characters. There's many ways to do that. Okay, every 4 characters. Every 4 characters must be an element in a list. Okay, if you know how to use while with substring. Okay, so that's a recommendation from Louis. Okay, we can do that, while with substring. There are many ways. Okay, so we can also put it into a buffer. For example, suppose we have that. Open a new buffer, we can create a temp buffer, and let's say let's say this is a line. So we just move cursor 1 2 3 4, then we grab buffer substring no properties 0 1 2 4. You delete that, you grab that, then you delete region that, then you got that, then you can push to a thing. Okay, so that's one way. So so let's do the while loop. We can which way is easier? So let's do while loop, because while loop is more traditional to programming languages instead of the buffer text processing. Okay, so while loop. So while, so let's say, so we have to give a example string. Let's say that. Okay, it's temp Okay, let's work on that. Just to test. Okay, so suppose this is a line while temp length, okay, equals to is not equals to 0, okay. So while it's not equals to 0, this will be slower because every time you process a string in Emacs, it's slower than if you actually have the text in a buffer. Just move cursor and deal with buffer. Let's push on. Okay, so while that temp is not that, okay, so push. So you got to push. So let's remove that. While push, let's say xlist, and this part will be a substring. Okay. Okay, substring. Let's say xtemp. So string is xtemp from from 0, index start with 0 to 4. But you also want to delete. Okay, so you do that, then you want to say modify. So this is not functional programming because you are trying to modify this thing. So set xtemp equals to this code. This time is from 4 to the end. Let's save that. Okay, let's see if that's right. So you need to okay, so you also need that. Okay, we have lots of local variables here, which is not good because they are global variables. Okay, but suppose, so right now it's nil, so empty list is nil. We start with nil, empty list. So here will be that. Okay, so let's double check. While not equal length, so when the length of temp string is not 0, you take the substring, the first 4 characters, you push it into temp list, then you reset the temp string by taking the last. Okay, so if we do this, let's hope it's not infinite loop. Okay, let's evaluate that, show the pink window, evaluate that. The pink window shows all my command calls and the keystrokes in command calls. Okay, then now let's evaluate this. Let's hope the Emacs doesn't go into infinite loop. Okay, do it. Okay, that's done. Now let's move to temp list and describe variable. Let's see what's the value. Okay, double check. Okay, incorrect. Okay, we got something incorrect there. 1, 2, 3, 4 characters. So why is it incorrect? So CT, wait, what? Substring, what? So the first substring we got is that. What is that? It's taken from the last. So yeah, it seems this is, oh, this is reversed. Okay, this is reversed. We got reverse it. Fucking idiotic. Because we are using a push. You know, you push to the front. So reverse. I believe there's a reverse list, okay, which it reverses the order of a list, reverse sequence, that's right. So we want to imperative programming, fuck. Lots of modifications of the, we don't want to do that. We you know, it could, well, but Emacs Lisp is not that much functional. Anyway, let's push on. So we don't want to end up 3 hours like the other days, okay? So now we reverse it. Void variable reverse. What? Oh, this part should be that, okay? Evaluate it. Now it's correct. Let's see. No, it's not correct. What is this? 1, 2, 3, 4. Oh, that's correct. Okay, 1, 2, 3, 4. Then 1, 2, 3, 4. Okay. Wait, which one are we working on? We are working on this one. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Then one. Then okay. So the R part. Okay, so maybe off by 1 error, maybe. So let's try again. So actually, let's use a let. Okay, so we move this to a let group. Because that's one unit, that's one semantic unit. So we have now temp variables, okay? This is just for testing, okay? Let's do it again. Okay, let's see. 1, 2, 3, 4. No, this is not right. Okay, so this should be 4. This is 4. Let's try that. Do it again. Debugger entered. Args out of range. Ah, fuck. Let's simplify, okay? Let's just simplify. Okay, so let's see, where did we debugger entered? Why is that? Let's see substring documentation, okay? Substring from 2. Now, they are inclusive, right? Like, if you say 1 to 2, it includes the 1 index character and 2 index character. Okay, return new string whose contents are substring of string. The return string consists of the characters between index from inclusive and index to exclusive. Fuck! I hate this kind of thing. This zero-based fuck. Motherfucking idiots like the Python. Okay, exclusive. Okay, so the exclusive, this it means just you do it 5 then. Yeah, so the first part is inclusive, the second part is exclusive. You know, people will argue, well, but actually this way is more easier mathematically, something that's bullshit. That's idiotic fuck. Like the C++ coders, they will say that. Okay, let's try again. Nah. Okay, we really need to think about this. Okay, so actually, substring. Oh yeah, this is. Yeah, so this is 4. Remember, it begins inclusive. Let's do it again. Fuck. Args out of range. What is the arg? Oh, okay. So actually, 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. Yeah. So you need actually. So this is like a tricky problem. Okay. So yeah. So let's do it again. Get out of that. Args out of range. What the fuck? Okay, maybe our logic is wrong. Perhaps use while with substring. Okay. Shit. I don't want to get stuck, you know. You're just gonna watch me stuck on this. Okay, we need to think instead of just let's just say, okay, so wait, you need to think. Okay, you can't just keep going. So you got a string. So, but our problem is right now with the 1 2 3 4. So 0 to 5 is correct, I believe. But so we do that one time, then 2. Wait, how does it? 1 2 3 4. Okay. So the next round start with 1 2 3 4. Okay, and then 1 2 3 4. Then 1 2 3 4. Okay, then the last round we should have still 4 characters left. 1 2 3 4. Yeah, so we should still have 4 characters left. So why is it arg out of range? Wait, set substring from the 4th. This part is wrong, I think. So substring. Oh, 0 indexed. What? Fuck. 0 1 0 1 2 3. What? Wait. 1 2 3 4. So basically you want to remove 4 characters. Okay. You want to remove 4 characters. The easiest way is just to actually do this. One, two, three, four, 5. Okay, so if you do that, you get 5. So that is the correct code here. Is that right? So let's try, ABC. Yeah, that's the correct code. And what about this? What about this part? Let's. Okay. This part is incorrect. Oh yeah, because zero based. Fuck. Okay. Yeah. Okay. So that is correct. Now let's do. It should work. Fantastic. Okay. Now you look the answer. So each one got an extra character. So each one got extra character. Then yeah, before you push, you want to trim string. Okay. Okay, so this part, okay. String trim. But where is the string trim function? You know, trim string is not, you know, it's added string trim, okay? So I think in Emacs 28 it's built in. You don't have to fuck. I think something wrong with my, it's describe function string trim. Yeah, it's built in, but I don't got the completion because my Emacs Lisp mod error, I think. Okay, I need to add that. Anyway, string trim, then you put that here, okay? That, okay, let's try it again. Run it. Fantastic, okay? So this is how you do. And there's extra thing we need to do. We need to make sure this, you know, given a string like that, we want to make sure we want to pad space at the end, just in case the input, you know, we just truncated. I mean, we want to make sure the string is in multiples of 4, okay? So pad, Jesus, Emacs Lisp fuck, because if you want to pad string, you have to require that, okay? Then let's search for pad. What? String p, where is the string pad? String equals string, compare string, string, substring, no properties. Blank string, remove prefix, remove suffix. String trim right, left. Oh God. To pad, don't tell me I have to write own function. Maybe you have to use format. Very annoying. Emacs Lisp. Let's Control U describe function. Control U apropos, okay? Let's search for pad. Pad right variable, okay? Common padding, search for string. Common pad right, common string pad. Now, string pad is in subrex. Oh shit, I don't have it on my page. I missed. Okay, so anyway, so string pad, let's go back. So this is what we want, okay? String pad, we want to, let's say some string. The length will be 4 times number of columns, okay? And optional padding, string pad, is it pad left or right? Yeah, fuck. Pad string to length using padding, okay? If padding is nil, space character is used, okay? String is longer than absolute value. No padding is done. Start is nil. Padding is done to the end of the string, okay? The nil padding is done to the start of the string. Okay, so we want to pad at the end, so nil, okay? So optional, so padding which is space, okay, start at the end, okay? So that is the code, and we want it to be, we want to modify this temp, okay? There. Okay, so let me show you what we're gonna. So that is the temp, okay, and neo, okay. So that is that. Okay, so and here is temp again. Okay, so let's try that. Evaluate that. Evaluate that. Ah, fuck. Number or marker P3. Wrong type of argument. Four times number of columns. What? It should be a number, right? String pad, string length, okay? String pad, string length. What do you mean number? So basically, wrong type of argument, number or marker 3. Oh, okay, so our number of columns, the value of that is a string. Okay, we need to convert that into a number. That's why this multiplication got fucked. Okay, so you need to convert this to a number. So all you have to do is string to number. Okay, that. Then put the whole thing there. Okay, that. Okay, evaluate now. Move back here. Evaluate. Fantastic. You see the bottom. That's fantastic. Okay, so but this is a sample code. You see, this is temp. So we want to actually, so let's move that, remove that. We want to actually put this block of code into this lambda. One complicated fuck. So this block of code, we need to put this into this lambda, basically. Okay, something like that. Now we just want to make sure that x, so the x is basically becomes x temp. Okay, so yeah, so we don't need this x temp. That's the input. Okay, so we don't need that. Okay, and now instead of x temp, let's name it xx. So the code becomes more clear. Oh God. Let's change this to xlist, okay? And now xtemp becomes xx. Okay? Somewhat easier to understand. So now this xlist is temporary. Okay, so we need to let's comment that out. Let's put it at the bottom. Okay, so those are things we don't care. Hicks, I wanted to check again regarding the Emacs tutorial I bought. You mentioned you wanted to send it. I thought I sent. So remember, you know, like there are one people or two. I don't know your email address. Like I don't know if you send via Amazon or what. Sometimes I don't have the email address. So email me, please. Okay, email me and say the date, and say did you pay via Amazon gift card or via PayPal. So give me a date, give me a source of your payment, PayPal or Amazon gift card, and add your email. Put your email me. Okay, you can find my email me, and because I don't know where, I cannot send it. I don't have the email address, and these names, you know, I don't know who you guys are, you know. So do that, please. Okay, so now let's get back to, so now we have, God, this is already 1 hour. Okay, so code of conduct. I mean, code of advent of code. Code of conduct. My ass. So now where are we? So we got a number of columns, and we want to yeah. Let's refresh. We want to turn each line into a list. Okay, so list of lines. Okay, so let's declare a variable. Okay, so yeah, list of rows. Okay, so in the beginning it's nil. Okay, that's going to be our matrix. A nested list. Each element is a list of the string of boxes. Okay, so for each row, okay, so let's just say matrix. Box matrix, okay? A list of lists, each sublist is a row of boxes. Okay, so this is the ultimate representation for this thing. And then we're gonna do a transpose on this Xbox matrix, okay? So, but for now, Xbox box lines, then after you do this, then you want to push this X list into the box matrix, okay? I think so. Okay, double check. While that finished, then you reverse the list, then you push the list into this matrix. Okay, so at the end we're gonna have this Xbox matrix. So let's comment out. Okay, and here, okay, build the Xbox matrix. Okay, it's evaluated. Do it. Wrong type argument, character P, but instead of you got a string. Yeah, where is that from? Wrong type of character. So let's evaluate that. Evaluate again. Okay, toggle debugger. I mean, debug on error disabled globally. Actually, enable it. Okay, let's run it. What is the wrong type of set Q? Wrong type of argument. Requires a character, but you got a string. Okay, so must be here. Let's see, set Q. So what? Wrong type of argument requires a character, but got a string. Wait, why is that? So can we just then let's print, okay, message. Okay, so we know each step. Let's see. So okay, so actually it didn't even, so let's close that, evaluate again, show message so far. So it's just one error. It means before even it gets to the loop, there's an error. What? So let's check describe variable. Is that still Xbox lines list? Yeah, that's the input. So why is the first one element 0? Okay, so we need to look into that. So number of columns value is 3, that's correct. And what is the describe variable? Xbox lines list. Ah, we got the, you see the first line, we don't want that. That's okay, that's the input error, so we want that instead. Yeah, okay. So run it, let's rerun everything. Okay, input parts, run it, okay. Xbox's line list, run it. Yeah, 1 2 3, that's correct. Okay, so far so good. Then set number of columns, run it 3, correct. Okay, then Xbox matrix, run it neo. Now we got a spelling error. Let's fix it. Matrix. Okay. Now we have lots of global variables of garbage because we changed the variable names. Okay. So anyway, run it. Now run this. We still got that. Fuck. Wrong type argument requires a character, but got a string of one space. Now set q, so the error came from set q. Okay, so but so the error came from set q. String pad. Okay, let's do something. So here we are modifying the parameter. You know, usually I don't like that. So let's change the parameter just to x, and let's create a temp variable of xx so that we don't actually modify the input argument. We modify xx, which is our own temp argument. I mean temp variable. So this way, you know, we don't modify variables because that's not good for functional programming. Okay, so let's run this. Let's see. It's still got the same error. So So what is XX? Do we have something leaked? No. Let's see. So what is this describe variable? Okay. That's a list of lines. That's right. Oh, the last one. You see, we need to drop the last one because the last line is just a column number. We don't want that. We Okay, so we want to drop the boxes line list. Okay, so we need to here then we need to modify again. So we want to drop the last. Yeah, when you have a list, you want to drop the last item, which is very slow. Yeah, but what you gonna do? Okay, now I see that it will be much more efficient if we put this whole input into a buffer. Then we do text manipulation, text processing. Like in Emacs Lisp, you can say move cursor to the nth line or nth column, then just delete 4 characters backward or forward. That way, it's more efficient and faster, and than the way we are doing the traditional way of programming this thing. Because right now we got a Xboxes line list, but then we need to drop this last item, which is problematic. We delete the last item in a list, which is problematic with the list data structure. So, but anyway, let's do it. Okay, so yeah, the very extremely inefficient way to do it is you do it this way. Okay, let me show you. Extremely inefficient way is you reverse it, then you call rest. Okay, and I don't even have, rest is a drop the first item. Yeah, you can just say cadre. Okay, idiotic Lisp. Okay, anyway, so you reverse it, then you drop the first item, then you reverse it again. Very inefficient. Okay, this is how you drop the last item, which is the list of lines. Okay, oh god, we cannot, let's do it again. Okay, and you cannot do this before you get the number of columns first, so it's all problematic. Or another way is we turn this list into a vector first. So we work with a vector, which is just like Python's tuple, but each element can be changed. So, but anyway, let's push on. So do that, evaluate, do that. Okay, now you see the bottom, there's no list of lines. Now do that, now do that. Wrong type of argument. Character P. Where does that came from? It came from setQ. Wrong type of argument. So it's expecting a character, but it got a space. So let's push. Okay, so let's do message. Okay. Evaluate. So we got D. So the first item is D. Now, where does set Q occur? There. Okay, so actually, so let's make this, cut this line, put here, okay? Let's run it. Let symbols function definition is void. Oh yeah, so okay. Run it. Let run type of arguments. Okay, so it came from here. String pad x. Run type of argument. Oh, so what the fuck with the string pad? Padding, use padding. If padding is nil, the space character is used. If not nil, it should be a character. Fuck! That's a problem, you see? Because in Emacs, Lisp, a character is a different data type than a string. So, you know, if you want a space as a character, you have to say, this is how you represent it, okay? 32, okay? You just say 32. Because a character is the same as integer. So if you do that, that will work. Run it, you see, no error. Now, describe char. Now describe char. Describe variable, box matrix. You see, we got it. It's a, you see, 1, 2, 3. Now what's oh yeah, then you have to reverse it. Yeah, some of these got wrong, okay? Some of this is wrong. So you have to reverse box matrix, okay? Okay, now describe variable. Yeah, so it corresponds to that. But you got some issues. What the fuck is this? Okay. Comments, no comments. Okay. Well, where is you know, Jacob L? I don't know where he is, because he's requesting this video. Okay, so we need to find out. We still got some errors. Oh, empty string. What? So what is the value? Oh, the value is correct, but if you say describe variable, then you got that. Fuck. I don't understand. But if you just eval buffer, let me show you, okay? You eval last sexp, okay? Then go to the message buffer, you can see the value is correct, you have empty strings for the value Xbox matrix. Okay. Anyway, let's move on. So now we have a matrix that represent this bunch of boxes. Now we want to do transpose. This is gonna be painful. Define. Okay, so in Emacs, you don't do so we're gonna write a function transpose. Okay, transpose a nested list. Okay, the transpose a matrix. Okay, so the matrix is assumed to be 2D, okay, and assumed to be nested vector, okay, not list. Okay. lots of code to do. Comments, questions? Okay. So we're gonna write this F transpose. Yeah, let's say XOR transpose. Okay, so first of all, you want to turn this convert this into a vector of nested vector. Okay, so how do? You want to convert the list into a vector. You have a nested list. You want to convert it to a nested vector of vectors. Okay, so how do you convert? Well, go back to Emacs Lisp. Sequence types, you want to convert a list into vector. The difference is that a list is a linked list, so it's not efficient if you want random access. So if you want to represent a matrix, such as used in mathematics, linear algebra, you want to constantly access, nth column, nth element, then nested list of Lisp is not efficient. You want to use the vector data type, which is basically nested array. Okay, so right now we want to convert this box matrix, which is a nested list, into a nested vector. Okay, so let's see how do you do that. I know because basically you use map concat. Okay, wait, convert this to string. There is a append join list prepend. Okay, you want to convert the list to vector. Okay, list to vector. So how do you do that? Vector. Okay, create vector, field vector, length, get element, change element, nested vector. Okay, join vectors, convert list to vector. There, v concat. That's right. Join any sequence types and return a vector. Okay. Yeah. Okay. List and vector are both sequence types. Okay. So yeah. So v concat. Okay. Okay. So actually you want to map Q. Let me just show how it works. Okay, so let's say you have a list 1 2 3, then you do that, you got a vector of 1 2 3, correct? Okay, what if you have a list of list? Okay, 1 2 2 3, okay, which is a matrix. Okay, evaluate that, you see 1 2 let's say 3 4. Okay, so this part is a nested list. Now when you do that, you see it doesn't dive in. It only convert the first level of elements. So if you have a nested list, you need to map the conversion to each element. Okay, so you need map car. Okay, map car. Okay, map a function to a sequence. Okay, the sequence is going to be that. And what is the body? The body is gonna be basically something like that. Okay, so the input, so you want to map each x, that returns a vector. Okay, so map that function into this. Okay, and it returns a list. Okay, that's it. Okay, so let's do it again. Let's see what's the value. Okay, that's a nested list. Now let's do this. Fantastic. Now it's, you see that now it's a nest of vector. Oh wait, you see the outer bracket is still paren, so that means the whole thing is still a list. Right now it's a list of vectors. You want a vector of vectors. Okay, so you have to do this again one more time, and this time it's just that. Okay, run it. Go to the bottom. You see now the outer bracket is a square bracket that represents a vector in Lisp, in Emacs Lisp and Common Lisp. Okay. God, fuck. So in fact, let's just put it here. So that's one line. Formatting problem. Okay, so now Xbox matrix is a nested vector of vectors. Okay, now we want to write the transpose function that transposes it. God, now it's already what, 90 minutes. Okay, after we write the transpose, then we are pretty close. Then God, then we transpose it. Then we got a columns as our data, but then we need to convert it to a list again, because for a stack it's much easier to represent them. It's much more efficient if you to represent a stack data structure as a list data type. Oh God, all this conversion back and forth is very costly. But we are working with Emacs Lisp, So I'm discouraged now. I'm discouraged. Should we? Who is watching? Should I go on? 3 people, 8 people. Oh, 8. Reasonable, numerous. Comments, guys. Comment. Okay, where are we going? So you see, this problem actually took us 3 hours in Wolfram language too. This problem, day 5, advent of code, day 5, is it actually took us 3-4 hours to actually implement it. So here is the Mathematica code solution, 10 lines of code. And the problem 2 is just change of a single function. So basically 10 lines of code in Wolfram language to do this day 5. And in Emacs Lisp, so far we have about 30 lines. We haven't write the transpose yet. So once we write the transpose, we do the transpose, then we need to convert vector to list. Okay, yeah, that's so I always miss that suggestion, just get it to work, then talk about efficiency and stuff. Okay. Okay, let's do. Okay. Okay, we need to write the transpose function. Okay. Yeah, I'm thirsty. So transpose function, so that means, so if you have A, B, C, D, E, F, then after transpose, it's going to be like, it's going to be like AD, BE, CF. Okay, that's what transposition means. Okay, so row become columns, column become rows. Okay, so you want to go through each element and swap. How do you do this? God, in Wolfram language, it's built-in. It's just one line. There, but here, so okay, so let's see a propose. Let's see if there's transpose characters. Those are not. Those just swap two positions. All these commands, transpose region, transpose sentence, they just swap two positions. So that's not what we want. Let's see, Control U a propose. Okay, then transpose. Let's see what we get. Transpose char, transpose line, transpose sex. Yeah, there's no built-in function. Are we sure? Yeah, I'm pretty sure. Unless you turn this nested list into org mod table form, then there's some function to transpose the text, I think. Okay, so now let's go back to, we want to make sure if there's any built-in function. That saves us 10-20 minutes. So built-in function for transpose a list or a vector. So how do we find it? Sequence type. Okay, so sequence functions. This sequence of functions is new about 7 years ago. So maybe they have a transpose now. Let's search. No, I guess not. Sequence into, filter, sequence take, sequence drop. Oh, we could have used sequence drop to delete the last element. Yeah, that's interesting, but it's inefficient. Let's see. Describe function sequence drop. Let's see how they implement it. Length, sequence drop. Remove the first n elements of sequence and returns. Oh. Yeah, it doesn't make sense. It removed the first n. We want to remove the last item. So, anyway, let's forget about this. Okay, transpose. So how do you write this? So of course, you map. You need to map for sure. Map car. So first of all, the transpose, you have a. Okay, so let's say you have a matrix. Okay, so matrix is your input. So you want to map to this matrix. Okay, so how do you want to map it? So, here's the body. Okay, so how do you map so for each one, you get the position. So you want to push. So first of all, let's get some variable. Let's get the dimension. Okay, so column count. Okay, column count equals to the length of, no, that's row count, but close. So let's do this. So we have row count, then we have column count. Column count would be the first element of the matrix. The first row of the matrix, then the first row of the matrix, then you take the length, that would be the column. So you got the row count and column count. Then you wait, is there a partition? So one way to do this is that we just loop through every element, map car, then we just create a flat list, just push to a result list. So we have one giant flat list. Then we use the row count. Wait, which one? Then we use the row count. To every row count is one sub list. So, but to do that, we need a partition function, list partition. Let's see if there is a. Oh, there it is. Fantastic. Partition. Return a list of the elements of sequence grouped into subsequences of length n. That's what we want. Fantastic. Now make things much easier. So so first of all we do this. And let's add that so we don't. So we're gonna use this later. Partition. So basically here will be row count. And something like that. Something like that. So now we need to define a local variable flat list somewhere here. So now we map, and for each one, flat list is a empty list. So empty list is nil, or you can write it this way, equivalent. So we want to every encounter of an element, we just push it to flat list. Push the X into it. Fantastic. And we don't care about the result, so we just use map C. Then we got the flat list. Then we just partition into row count. Fantastic. We done. I believe that works. So let's clean up. I believe that is a code. Let's move this thing here. So so now we evaluate this function. Now we have it. Now let's do some testing. Then let's see. Let's start transpose. Let's do transpose. And we're gonna have a vector 1 2 3, and we're gonna have 4 5 6. That's a nested vector, a matrix. Now let's eval wrong type of argument, Lisp P. You got vector. So somewhere here is wrong. Oh, here, car. You can use car for a vector. Okay, so here you want a ref. Okay. Matrix index 0. So because the 0 indexed fuck, the idiotic 0 indexed from C fuckheads. Okay, so okay. Evaluate the code. Evaluate this again. Fantastic. Wait, it's incorrect. We should have 142536, okay? But close. We need something to fix. Let's see. Sequence partition is still sequence n. Sequence, so row count. So wait, so the result will be, when you partition it, so you want a column count. Column count, so here should be column count. Okay, eval, that's still incorrect. Oh, wait, you need to return. Did we return the thing? Return list of elements. Return a list of elements of sequence. I don't know what's going on with that. Let's try it, okay? Let's say 2. Let's say 1, 2, 3, 4, 5, 6, okay? You should return 1, 2, 3, 4, 5, 6. Yeah, that's correct. What if you have 7? Does it drop? No, it doesn't drop, but you have that. Okay, so this should work. Okay, so now let's try a list instead. Okay, 1, 2, 3, 4, 5, 6. Okay, that's correct, but the result is a list. Okay, now if you do this, the result is still a list. So you need to convert the whole thing into a vector. Okay, so you can just say vconcact list to vector. Okay, so what's the documentation for vconcact? Concat all arguments and make the result a vector. Concatenate, yeah, okay, so the result is a vector whose elements, okay, each element may be vector. Okay, vconcat, that's what we want. So we just say yeah, that's right. So vconcat, okay, vconcat, let's see. So that's the result, but why is our function is not incorrect? 4, 5, 6, 1, 2, 3. No, we got something wrong. Let's see again this map. So map to the matrix. Now does map takes a list or vector or general sequence? Okay, it can take any sequence. Okay, that's good. So map, we map to each row at a time. Where is our talk show? Which one? Yeah, so we map. Here a row is the a list of stacks. So NZ, God. So what is let's show the result here so it's easier to see. So here is the example. So Xbox matrix, okay. So we map Xbox matrix. Wait, let's see, let's just say that it's incorrect. Okay, incorrect. Hi, sorry for off topic. I'm trying to recreate your floating window workflow on OpenBox, and I think you were right. Thank you. Yeah, so that's about the tiling windows thing article. Okay, so let's go back here. I don't know. You know, it's already close to 2 hours, and we have not done. But we are close. I want to get up and walk for 5 minutes, but now our transpose function is incorrect. Yes, index from 0 is bad in general. Look up XARLi. Should array, you know, search for XARLi array index start from 0 or 1. You'll find my article. Okay, so of course the C++, Rust type of people, they will disagree vehemently. You know, they will say, oh, blah blah, but array memory or whatever, you know, but they don't, you know, I don't think they know stuff. Well, that's not fair, but you know, but you know, but here is one reason. Okay, basically all math oriented programming languages, their index start with 1. You know, typically the programmers, the C++, Rust, low-level types, they will say 0 is more appropriate because 0 is, you know, is for mathematics. When you have a 0-based sequence, it's much more intuitive to, you know, concatenate or whatever. That's what they think. You know, they somehow, these programmers adore mathematicians. You know, they adore Knuth. You know, they think 0 is the proper index starting because of mathematical properties. But actually, all math-oriented programming languages, their index start with 1, such as Wolfram language, Mathematica, MATLAB, Julia, APL, or any array languages. You know, math-oriented mathematicians, their index start with 1. For example, matrix, they say first column, first row. They don't say 0th column, 0th row. So the programmers are idiotic to the extreme. You know, they have like some kind of admiration to mathematicians, but they themselves don't know anything about math. Then they insist, you know, arrays should start with 0, things like that. And for example, these hackers, Richard Stallman, they will say, you know, 4 principles of freedom, principle 0, something, you know, start with 0. Idiot. And Knuth too, you know, the prototypical hacker mentality, Knuth, you know, like he has chapter 0 in his other programming, chapter 0. You know, but Knuth is a mathematician, that is for sure. But in general, math, okay, mathematicians, they start with 1, not 0. Anyway, so that's that. Okay, I don't know, you know, I should stop or take a break. You know, it's 2 hours now. Okay, let's at least finish writing the transpose. We got an error somewhere. So row count is the length of matrix. Okay, let's print row count. Okay, just to be sure. okay. God. Let's print column count, okay. Let's just print it, okay. Now evaluate it and evaluate that, and let's go to the message buffer. So row count is 2, that's correct. Column count is 3, that's correct. And now we want to partition it. We want to partition it to row count, not column. So this is wrong. What? Row count is 2 rows. Column count is 3. So the new one, wait, we should partition it to what? Just try it. Okay, so I think I know something's wrong. Once we map, okay, after we map it, you see, after you map it, you got a wait. So flat list, push X. Oh wait, so what? Wait, oh I know. So you need to do nested map. That's right. Yeah, that's right. Yeah, fuck. Okay, so you need to do nested map. Okay, so you map because you are mapping to each row, and for each row you need to map into each item in a row. Okay, so nested map again. Okay. Okay, and here is X. Here should be X, and here is a new variable Y. And what do you do with the body? You do this. Okay, you push Y to it. Okay, that's our error. Nested map. Okay, and the result should be row or column count. So I need to think about this. Okay, so Happy New Year's. Hello, Coffee House. Yeah, so yeah, end of year. So a lot, I have a lot of thoughts. Let's digress a little bit so it's more fun. So 2022 is a great year for me, and I think it's a great year for America, for and probably for the world. So many things happen. I wonder, maybe I should do more talk show and talk about it. So many things. Okay, yeah. So I hope you guys have a great Christmas and holidays. Okay, so let's finish this transpose, and let's do it. There it is, 6.5. Okay, something is wrong there. Then yeah, we need to reverse the order. Oh God, Jesus, this Lisp, yes. Wait, so do we need to reverse like twice? Yeah, we need to reverse for each row, then we need to reverse the whole as well. And for now, let's just return. Okay, first of all, let's just return the flat list. Okay, run it. Okay, so you can see the answer is reversed. So you need to 1 2 3 4 5 6. Okay, so you need to reverse it because of the push, because we are using push, which is prepend. It would be nice if we just change this push to append, but it won't work well. It's very inefficient because you have the list. Because in Lisp, you're stuck with this list data structure, which you can only efficiently prepend or remove the first element. If you want to append, that's very expensive. The fucking Lisp idiocy with their cons. Every time I talk to these people, they don't agree. They don't get it. So if I can just change this to append, then we are done. But it's extremely inefficient to do to append. There's not even built-in function to do it. So anyway, so now you reverse. Okay, so now you reverse run it. Okay, so you see that's the answer. Now you partition. Okay, now you partition it, sequence partition, and turn it into a vector. But before we do that, let's just say return that. Okay, run that. Let's see what's the result. Okay, there it is. 1 2 3 4 5 6. You need to reverse again. Wait, when you partition, it reversed the order again. What the fuck? What the fuck? Jesus. Set Q partition. Return list of elements of sequence group into subsequence of length n. The last sequence may contain less than element if n is negative. Okay, your relevant function document sequence. But it reversed the order. Does it? Wait, it doesn't. So what? Let's try again. Just make sure we are not run it. 6 5 4 3 2 1. Okay, so we do want to reverse it. Okay, reverse. Oh, I know what's going on. Okay, run it. 1 2 3 4 5 6. Correct. Now we partition, but you remember you do have to reverse this thing. That's right, we forgot. Okay, now we do it. Run it. 1 2 3 4 5 6. Oh wait, this is incorrect. It should be 1 4 2 5 3 6. Oh, that's right. Fuck, our algorithm is entirely wrong, and we wasted 10 minutes on this transposition. 1 2 3 4 5 6. The result should be 1 4 2 5 3 6. Can 1 4 2 5 3 6. Transposition. So how do you? So can we? So right now we are working on this transpose function. So we have a nested vector. So let's swap. Let's do the approach of swapping elements by their indexes then. So you basically, again, you do a nested map, nested map C, and the body of the map C will be not push, but to swap two indexes. We have two indexes here. One is X, one is Y. Okay, actually we don't even have index. Okay, so but if you want the index, you cannot use map C or map car. You have to use do times. Fucking very extremely tedious. You have to use do times if you do want the indexes of the array. So if you want to swap the items, you have to use indexes, to index. So that would be something like, array, for example, in Python, it would be something like array index I, index j becomes array index j I. Okay, you want to swap their values, and you cannot just do that. You need a temp. The fucking this imperative language, fuck. In Python, okay. For example, fuck, I just started Python. I don't want to start Python, nothing. Kill it, yes. God. Python mod, okay. So this is how you would do in Python. So array temp ij, get it to a temp, then that, then basically then temp, something like that, okay. Ij equals to then ji, actually ji, yeah. I just got backup. Oh, Flamio, hey, good morning. I'm about done though today, which is so. Okay, I think maybe I should stop because this is taking 2 hours. Okay, I should stop. I think so. Next day, I wish if you guys gonna request me to do some video, you guys should be here. Jacob, Jacob is a great guy though, but maybe he's okay. Gonna watch later. What the fuck? Anyway, so we have not written transpose. We are halfway, debugging and all, but it can be done, of course, to write this transpose function. And in fact, this transpose function will be generally useful in Lisp. So I'm going to write this maybe in another video or maybe offline. Then it's gonna be on my website, the code, transposition of a nested list of a matrix, very useful. So I can continue. In fact, it's almost like already there, but who knows, it might be another 10-20 minutes. Usually that's the case. So you just want to use do times, do times, so you get the index. You want to do a nested do times, okay, so you're gonna do times again, okay, so you're gonna do times, then you're gonna and this is gonna be j, ij, count will be the length of the row or column. Then at the body here, you're gonna be doing something like that, but in Lisp syntax. Okay, so let's do that next time. So thank you guys for watching. Okay, if you like my stuff, donate, Patreon me or PayPal, buy me a coffee. You can find the links on my website. Everything is on my website. Xadi code. All the way at the bottom, you'll see it. Okay, so Happy New Year and Happy Holidays. Thank you guys for watching. Bye. I'm gonna stop in 1 minute. What is this privacy thing? No idea. Okay, so today's code is pretty good until we haven't finished writing the transpose, and this weekend we don't need anymore. Thank you, hey Luis, thank you Luis for coming by, and Emma, bye guys. Okay, that's our code. Pop it back. Syntax correct. Show in browser. Let's see what we have. At the end of code, day 5 in Emacs Lisp live coding. Yeah, but failed completion. And okay, that needs to be fixed. Okay, and here's a code. Almost done. Another 20 minutes, I would say, we'll be able to solve problem A and B. They are very similar. Okay, bye.